All right, with the combination of 3.1 and 3.2, we're going to take what we know about or what we've learned about these angle relationships with parallel lines, and we're going to have equations set up. But we're going to need to review some Algebra 1 abilities first. We're going to have to review systems of equations. So if you remember systems of equations, great, move on if you think you know how to do it. If you need a refresher, I'm going to go through and talk about substitution and elimination. So substitution is going to occur when you have or you can set equal to one of your two equations to one of your variables by itself, nothing else with it, no 4y, no 3y, no x plus y, either y equals or x equals. That is the first thing you have to do with substitution. So if your equations aren't already set up with one of them being y equals or x equals, you're going to need to move or manipulate that equation. So for example, I could have originally started with 5x plus y equals 9, but all I have to do is subtract that 5x from both sides, and that gives me y equals 9 minus 5x, like I have here. So if it's not given to you like that, you can easily manipulate or move the equation to look like such. So once I know I have an x equals or a y equals, I'm going to take that y and place it in the second equation. So I'm going to substitute everything that y stands for. Everything that y stands for. This 9x minus 5 is going to go in place of our y, and I'm going to rewrite that out. So I have 10x minus 7 parentheses 9 minus 5x, close parentheses, equals negative 18. So I replaced the entire part that had y in it with everything y was equal to. And now I'm going to go through and balance my equation, simplify, distribute, everything I need to do. I've got 10x minus 7 times 9 is 63. I have a negative times a negative. So if I look at this negative and this negative 5x, negative times a negative makes a positive. 7 times 5 is 35x equals negative 18. And now I'm going to combine my like terms. I have 45x minus 63 equals negative 18. Again, some addition and subtraction. Negative 18. I'm going to bring my 63 over, plus 63. I've got 45x equals 45. Interesting. And when I divide that out, x is going to be equal to 1. So now I have that x, but I'm not done. When we have a system of linear equations, we have two variables we need to solve for. So I'm going to need to find both of these. So once I have this x, all I have to do is plug it into one of my two original equations. It does not matter to me which one you choose, but I'm going to go with the one that looks like it has the least amount of work. So I've got y equals 9 minus 5x, but I'm going to take that x and I'm going to replace it with the 1 I found and work this out. So y equals 9 minus 5, so y is equal to 4. So that is how we use substitution to solve a system of linear equations. Now I'm going to go through with elimination. And elimination is a little different, or a lot different. Elimination requires that we have our variables stacked on top of each other. So x has to be on top of x, y has to be on top of y. The equal signs have to be stacked on top of each other. And if we have any additional numbers, they need to be stacked on top of each other. The order does not matter. I could have y plus number equal x and y plus number equal x. That's fine too, as long as the correct things are stacked on top of each other. So they need to be stacked. The process of elimination, I mean, think about that word. Elimination means to get rid of. Our goal is to cancel out a variable. And in order to cancel out a variable, we need to have two things occur. One variable, one set of variables. For example, x's need to have opposite signs. and the same number in front. So what this means is if I'm looking at my x's, I have a 5x and a 3x. That isn't going to work for me. I need them to both either be a 3 or a 5 or some other number that's the exact same, but I need one of them to be negative. So a negative 5x and a positive 5x, or a negative 4y and a positive 4y. I'm going to need some combination of that. So I'm going to have to do some manipulation to these in order to get them in that place. So I'm going to go ahead and just try to eliminate my x's, because I know 3 and 5, they're going to have a common multiple of 15. So I'm going to multiply the entire top equation. I need to multiply the entire top equation by 3 to make that 5 turn into a 15. And so if I multiply that out, I've got 15x plus 12y, and we've got negative 14 times 3 equals negative 42. Secondly, I'm going to multiply the entire bottom equation by negative 5 because I want it to turn into a negative. And that negative needs to distribute to every piece. So I have negative 15x. 5 times 6 is negative 30y. 5 times 6 is negative 30. So now here is my new system, my modified system. And all I can do now is add top to bottom. So 15x plus a negative 15x is going to cancel out. 12y plus a negative 30y is going to give me a negative 18y. And negative 42 plus a negative 30 is going to give me a negative 72. So now I need to get that y by itself. So I'm going to divide by negative 18 on both sides. And y is going to be equal to 4. So just like we did with our previous problem, once I find one variable, I need to go through and plug it in to find my second variable. So now I need to find x. So I've got y figured out, but now we need to find x. So I'm going to go back to one of my original equations. I don't need to use the ones that we've multiplied with. So I'm just going to go back to 5x plus 4y equals negative 14. And I'm going to take that 4 and plug it in. So 5x plus 4 times 4 equals negative 14. 5x plus 16 equals negative 14. I'm going to subtract that 16 out, and we've got 5x equals negative 30. And then when we divide out, we find that x is equal to negative 6. So substitution or elimination, you can choose to pick one and stick with it if you do it really well, or if you know how to do both, go on a case-by-case basis depending on the information that's provided to you.